In this video, we're going to graph quadratic functions that are in general form, or what I would call standard form. And so again, here are my two forms. I can tell that this is not vertex form because it doesn't have parentheses. It's got this, just here's your ax squared plus bx plus c. You've got no grouping. Okay, so we are using this now. Now, here I want my calculator. Okay. Unlike last form, vertex form tells me my vertex. This one does not. So we have to do a little bit more work on this to graph this and find the vertex. Before we start though, I always like to determine whether this is going up or down. And you can tell if this is going up or down by looking at A. In this case here, my A equals 1. Because A is greater than 0, or because it's positive, I know that this parabola is going to open up. So we'll keep that in mind and make sure our final result is opening up. Okay, so for the first part, we need to find the vertex. Okay, we have a formula here to find that vertex. My vertex formula to find x is negative b over 2a. I've already listed up here that my a is 1, but I also need b, and b is 2 because b is whatever's with my x. So plug in your information here. You've got negative b, so negative 2. Over 2 times 1. So I've got negative 2 over 2, so negative 1. Now that's only half of your vertex. Your vertex needs to be an ordered pair, x comma y. So you get your y by plugging in your x. So go back to the original equation here. And remember, f of x is the same thing as y. And now these two y's, replace those with negative 1s. So I've got negative 1 squared, that has to go in parentheses, plus 2 times negative 1 plus 1. We've got 1 minus 2 plus 1, that's going to give me 0. So therefore, my vertex is x comma y, so negative 1, 0. I'm going to go ahead and put that on the graph, which is right here. We need the axis of symmetry. And your axis of symmetry is your negative b over 2a. Well, we've already done negative b over 2a. That's my x. So my axis of symmetry is x equals negative 1. So we're putting that right here through that vertex at x equals negative 1. So we know that this is going up. So I know that this side here is going to look the same as this side. It should mirror each other. Now I need to find my x-intercept. Well, when you look at this, your vertex is right here on your x-intercept. So this is your vertex is your x-intercept. If we go back to that first one I had, it's these right here where that vertex is that x-intercept. So we have 1. Now, again, let's pretend like we don't know that. We don't recognize it. What does that look like when we solve? Okay, well, to find your x-intercept, you need to let y or f of x equals 0 and solve for y, or solve for x. So that means we've got 0 equals x squared plus 2x plus 1. Now we can solve either by factoring, square root property, or quadratic formula. You're always going to use square root property, or I would always use square root property when it's in vertex form. When it's not in vertex form, you most likely have to use these two. Not always, but most likely. Let's always start with factoring. So it's in standard form. I have no GCFs. So my A times C is 1 times 1. My B is 2. So what adds up to 2 but multiplies to 1? Okay, hopefully you say 1 and 1. 1 times 1 is 1. 1 plus 1 is 2. This is an easy trinomial because my A is 1. So this factors to x plus 1, x plus 1. So when you set both of them equal to 0, you subtract 1, and you get both answers to be x equals -1. So whenever you only have one x-intercept, when you solve, you're going to get two answers, but those two answers will be identical. So therefore, my x-intercept is -1, because that's what we found for x. What do we put in for y? We put in 0. Okay, I would put that on the graph, but again, that's already there because that's my vertex. Okay, so now we need to find the y-intercept. There will be one y-intercept, and we'll find it by now letting x equal 0 and solving for y. When these are in standard form, they are very easy because now I've got y equals 0 squared plus 2 times 0 plus 1, replacing both of these x's with 0. Well, that's gone, and you're always going to be left with whatever your constant is. So we get y equals 1. So my y-intercept is 0. That's what we plugged in for x, comma, my y is 1. Okay, so we're going to plot that right there. 0, 1. That's 1 unit over. So I'm going to go 1 unit over the other direction. Okay, that is technically enough to graph. You can kind of make it, but if I want to make it more accurate, I'm going to go grab one more point. So I'm going to go just one more over right here to 1, and I'm going to plug in 1 real quick. Okay, this is not required. I just personally like to. So I'm going to go f of 1, which means I'm plugging in a 1 for both of these x's. So I've got 1 squared plus 2 times 1 plus 1. We've got 1 plus 2 plus 1. So f of 1 is 4, which means my next ordered pair is 1/4. So I'm going to go 1/4, which is 2 units away from my axis of symmetry. So I'm going to go 2 the other way. And now I have a little bit better idea of when I sketch that. And you could, of course, put in 2, you could put in 3, and you could go all the way as far as this graph would let you to get the most accurate graph. But I think 5 is pretty good, personally. Okay, and then let's find the domain and range. So your domain, as you go left to right, you hit arrow, arrow. This is all real numbers or infinity to infinity. And then your range, as you go from the bottom to the top, okay, be careful here. As I go from the bottom, here's where my graph starts. Look at the y-axis and that's at 0. And then it's going to go to infinity because as you hit that 0, the last thing you hit are those 2 arrows, meaning it's going to go up forever. Let's do one more example of graphing in standard form. All right, so first off, does this go open up or open down? Hopefully you see that A is again 1, and because this is positive, that means that this graph is going to open up again. Okay, I know that this is in standard form because vertex form would have some parentheses. So we are in standard form again. To find my vertex, part A or part 1, I need to use my formula of x equals negative b over 2a. We've already said that a is 1, my b is negative 6. So when I plug in this, we've got negative 6, we get positive 6, and then 2 times 1. So we have 6 over 2, which is 3. This is only half of your vertex. I only know that x equals 3 on my vertex. So now to get my y, I need to plug in x. Okay, so f of x is the same as y. So y equals 3 squared minus 6 times 3 minus 1. This is 9 minus 18, which is negative 9, minus 1, which is going to give me negative 10. So therefore, my vertex is x comma y, 3, negative 10. Barely fits on our graph. So 3, negative 10, which is okay, because I know this is going to open up, so it is going to open up this way here. My axis of symmetry is always going to be x equals your x equals your x coordinate. My axis of symmetry goes right through there at x equals 3. Now we need to find our x-intercept. Can you tell me how many x-intercepts we're going to have in this problem? Okay, I hope you said 2. If I know my vertex is down here and it's opening up, whether it's really wide or really skinny, it's going to cross twice. We find our x-intercept by letting y or f of x equals 0 and solving for x. And we will solve for x by either factoring using the square root property or the quadratic formula. So I've got 0 equals x squared minus 6x minus 1. I always like to start with trying to factor. I can't use square root property because I have a middle term here. But if I try to use factoring, my a times c is 1 times negative 1, and my b is negative 6. What adds up to b and multiplies to ac? Hopefully you said that there's nothing. When there is nothing, this means we have to use the quadratic formula. which makes most of you guys very sad. But that's okay, because we have practiced and we are experts and we are not afraid of the quadratic formula. So we have my quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In this problem, my a is 1, my b is negative 6, and my c is negative 1. So plug in your values. You've got negative 6 to give you a positive 6 again. B squared, so negative 6 in parentheses squared, minus 4 times 1 times negative 1. This is all over 2 times 1. So let's simplify. 6 plus or minus the square root of something all over 2. Let's figure out what that something is. So I've got negative 6 squared minus 4 times 1 times negative 1 to get 40. Forty can be broken down. 40 is 10 and 4, which is 2 and 5 and 2 and 2. So I have a pair of 2s. So that 2 comes out, and then these need to get multiplied back together to become 10. So square root 10 all over 2. Of course, we're not done. So you need to look before the plus or minus, before the radical, and at the bottom. Are all of those divisible by the same thing? Yes, they are. 6 divided by 2 is 3. Plus or minus 2 divided by 2 is 1. So you can do 1 square root 10 or just square root 10. And then 2 divided by 2 is also 1. So you can put that all over 1, but again, not necessary. Now, my math lab's going to want this as ordered pairs. More than likely, that is in simplified exact terms, which is this right here. Exact means you're not rounding. So this means that my x-intercepts are 3 plus the square root of 10, comma 0, and 3 minus the square root of 10, comma 0. Now, this doesn't really help us when it comes to plotting these on the graph. So just get some decimal equivalent so that we can graph these. So 3 plus square root 10 is about, let's go 6.2. And 3 minus the square root of 10 is about negative 2. All right, so let's graph those. We had 6.2, so 6 and some change. And we had negative 0.2. Now you can still make sure that those are accurate. Are they the same distance away from my axis of symmetry? This is 1, 2, 3 and some change. This is 1, 2, 3 and some change. So they're accurate. All right. Now 4. The y-intercept. You find the y-intercept by letting x equal 0, and then we'll solve for y. So I've got y equals 0 squared minus 6 times 0 minus 1. Those go away. We get y equals -1. So as an ordered pair, we've got 0, -1. 0, -1. And that is 1, 2, 3 units away. So we'll go 1, 2, 3 units away in the other direction. I've got my 5 points, so I don't need an additional one on this one. And so I have a graph. And again, make that as round as you can. It's not a V. And then lastly, we need the domain. And we'll need the range. Domain, go left to right. We go arrow, arrow. So this is all real numbers or -infinity to infinity. Range, go from the bottom to the top. So my most bottom y value is right here at the beginning of my graph at -10, which is included. And then it goes to arrows, which is infinity. So -10 to infinity.